Meron kayong questions regarding working stress design?
Sir, sa...
Sige po.
Sige.
Sige, Alan, ikaw.
Sir, tanong ko lang po if paano po yung method ng pag-solve sa box beam po. Yung parang box na girder po siya, sir. Para po as the example na gano'n.
Box girder, yung hollow box?
Yes po, sir. Yung sa irregular shapes po.
Okay. Okay. So, yung basic lang naman sa working stress design is of course, meron tayong investigation and design problem. So, ang kailangan in working stress design is to solve for the value of K. So, for investigation, ito yung value ng K natin. Then, for design, ito naman. So, kung mapapansin niyo with regards to investigation and design, sa investigation, given yung section natin. Okay? And then, AS, B, and D. Okay. So, dito sa formula, once na nakuha mo na yung K, makukuha mo na yung J. Actually, dalawang variable na kailangan mo, yung K and J. So, pag given yung design, you can solve for raw. Okay, so yung raw is just simply AS over BD. Then the N, of course, ES over E of C. So from that, masolve mo na yung K. So ang nakakalito lang dito, kailan mo gagamitin yung sa investigation saka sa design. Sa investigation, of course, if you are going to solve for the stresses or the moment capacity of the section. Okay. For design, all is unknown. Okay. Unknown yung B, unknown yung D, unknown yung AS. Kaya dinerive natin yung formula ng K in terms of given material stresses, yung FC, okay, which is equal to 0.45 F prime C. Okay, yung Fs naman is given, either 140 megapascal or 170 megapascal for grade 40 and grade 60. So once you solve for K, you can solve again for the value of J. Since sa design, ang unang hanapin natin is yung ratio o yung dimension. So in this formula, there are two unknowns, B and D. Kaya gumagawa tayo ng ratio. Let's say, for example, you set up B is equal to 1/2 of D, or D is 1.5 of B. So depending on the design requirement or the architectural purposes, or for optimal, of course, yung D natin is ranges from 1.5D to 2.5 of B. So once you solve for AS or your BD, next is to solve for AS. So yun lang naman yung basic formula sa working stress design. But take note that this formula is only applicable for rectangular section. Okay. So for any section, the basic formula, either rectangular, T-section, or irregular, the basic formula is yung basic stress pa rin. Stress is equal to MC over I. Okay? So in determining for I, okay, what we need to do is to convert the section para maging homogeneous siya because this formula is based on the assumption that for the homogeneous section, di ba? Sa previous mechanics nyo or strength of materials, this was derived based on homogeneous beam. Tinatawag natin na beam formula. So, i-convert into single material. So, i-convert into equivalent concrete section. So, yung rectangular natin, i-convert na to equivalent area of concrete section, which is equal to N times AS. Okay, so once converted, the next step is to determine for the location of the neutral axis. Okay, so how to solve for the location of neutral axis? So just choose an arbitrary region. Okay, so this is the compression side, this is the tension side. The moment of area above, okay, the area multiplied by the centroid with respect to the neutral axis is equal to the area, moment of area below. So yun lang yung basic formula. So once you solve for NA, you can now solve for INA or the moment of inertia, centroidal moment of inertia or moment of inertia at the neutral axis. So pag solve mo na yung INA, solve mo na yung from this formula, you can solve for stresses or moment, di ba? Pag steel naman, Fs is equal to moment of steel, C, steel, divided by INA. Kaya lang, yung INA natin dito is based on concrete. So, kukonvert ko naman siya into equivalent steel. So, magkakaroon ka ng divisor na N. So, pag kinuha mo naman yung FC, okay, MC, C sub C, divided by INA. So, in this case, you don't need to convert, okay, into concrete kasi ito na yung INA is based on concrete. So, pag yung sa tubular section, okay, so meron ditong AS. So yung tubular section, although this is a regular section, but it will fall under irregular if the neutral axis will fall on the web. Pag ito yung neutral axis, location neutral axis mo, magiging siyang irregular section. But if the neutral axis fall within the upper flange, okay, magiging siyang similar sa rectangular section. So paano malaman na yung neutral axis mo will fall above and below? So ang first, okay, ang first treatment is mag-a-assume ka ngayon na yung neutral axis mo is located exactly at the junction of the flange and the web. So dapat, okay, makuha mo moment of area above and moment of area below. If the moment of area, okay, above is greater than moment of area below, so what does it mean? Ibig sabihin, yung neutral axis mo above dun sa junction ng flange saka web. Kasi dapat, di ba, sa neutral axis natin, mag-equal dapat yung moment of area above should be equal to the moment of area below. So pag nag-equal itong dalawang to, yung neutral axis natin nasa junction. Pero pag greater yung moment of area above kaysa moment of area below, ang neutral axis mo is located dun sa upper flange. So didesign mo siya as rectangular beam section. And if the moment of area above is less than moment of area below, okay, yung neutral axis mo will fall below the junction of T-flange and web. So dito ngayon magkakaroon siya ng neutral axis. Kaya ito magiging X value ngayon yan. So solve mo ngayon yung value ng X. Okay, so lagi tatandaan, ito yung basic principle. Ito yung basic formula. Either rectangular, doubly reinforced, singly reinforced, irregular section, T-section. Ito yung basic formula. This one is only applicable for rectangular section. So, di ba, yung derived to is based on rectangular section lang. Okay?
Thank you
Clear?
po, sir.
Meron pang questions?
Good evening po, sir.
Yes.
Di ba po, sir, sa quiz po kasama po yung TBIM po?
Yes, kasama yung TB. So, lahat
Pwede,
ng work
pwede po ba kami humingi ng sample problem po tungkol po sa TBIM po?
sa T-beam, okay. Sa T-beam, sige, pwede rin. Okay, maganda tayo sample sa T-beam. Okay, so let's say for example, we have, okay, hanapin ko lang yung T-beam natin. Yung T-beam naman, ano lang siya, special type of regular section. The only difference there is the another requirement of the code is yung dimension ng flange natin. Okay. Irregular section. Problems na corrupt yung file. Saan na corrupt? Yun na sample. Okay. Okay, sa T-beam naman, ang dimension ng T-beam in case for monolithic construction like this one, ang another requirement of the code is to determine the effective flange width. Okay, ito yung effective flange width. So, the effective flange width, okay, pag T-section siya, ito yung requirement siya. So, whichever is the minimum between these three, span L over 4. So, 1/4 of the span. BW plus 16T. So, your BW, okay, yung dimension nung width ng beam sa bottom, or center to center spacing. So, yung center to center spacing. So, whichever is the minimum between the three, ayun yung governing effective B, effective flange width. Okay? Then for T-beam, wherein end slab siya o end beam siya, so parang letter inverted L siya. So yung requirement naman ng code, yung flange width niya is minimum between span L over 12, 6 times thickness of flange, kung yung thickness ng slab natin, or center to center spacing of the webs. So dito sa problem, okay, let's say for example this one, okay, we have predetermined or already computed effective width, okay? So the effective width is 900 millimeter with thickness of slab 100 millimeter, and the centroid from the bottom of the slab, the center of the reinforcement is 500 millimeter. And the effective depth, of course, effective depth is just simply the summation of 100 plus 500, which is 600. And the plans width or the width of the web. So this we call this one as the web. This is the plans. So the width of the web is 250 millimeter. Okay. So from this given problem, so we don't know where is the location of the neutral axis. So as I said before, it might be on the plans, within the plans, or within the web. So first, okay, first is to assume. So lagi ka lang mag-assume. Although you can directly compute, okay, pwede mo i-assume na agad dito yung location ng neutral axis mo, but the problem is pag mali yung na-compute mo na mali yung location ng neutral axis mo na assumption mo, ang magiging answer mo is negative. So pag naging negative yung answer mo, matataranta na kayo. So first, so this one is 900 millimeter. Okay, this one is 250. Ano yung AS natin? AS is 328 millimeter diameter bar. So meron tayong AS. So I just represent the 3 bars into single bar, okay? 3 diameter 28. Then the centroid or the effective depth, D is equal to 600, and then the plans or the top plans thickness is 100 millimeter. So if we assume that the neutral axis is located at the junction between the plans and the web, okay? So the moment of area above is equal to, so 900. So just consider the area of the plans, which is equal to 900 times the thickness 100. Then the lever arm, of course, the centroid of the rectangle is located 50 millimeter above the junction of the plans in the web, so 50. So this will give a value of, okay, ilan yan? Can you compute, please? .5 times 10 to the 6. Okay. So 4.5 times 10 to the 6 millimeter cube kasi moment of area cube. Okay. Then the moment of area below, okay. So the moment of area below, first is we need to convert the equivalent area steel into concrete section, which is equal to N times AS. So in the given problem, 28 megapascal and grade 60 reinforcing bars. So N is equal to ES over ES of C. So ES is constant regardless of the grade of steel to be 200 times 10 to the 3 megapascal or Newton per millimeter squared. Then EC is 4,700 square root of F prime C. Okay. So 4,700 square root of F prime C is, this one is applicable for normal weight concrete, meaning the aggregates or the sand and gravel is normal weight, meaning standard siya. Otherwise, this will not any more applicable. So pag hindi na standard yung unit weight ng concrete natin, kasi meron tayong mga lightweight concrete na tinatawag. Ginagamitan natin ng mga lightweight aggregates, like for example, yung mga volcanic sand, okay? O kaya yung mga gravel na medyo mas magaan compared sa standard. So, iba na yung formula nung is of C, of modulus plasticity of concrete. So in this case, F prime C is 28 megapascal. So N, okay, is equal to, so please compute the value of N. So take note that in determining for the value of N, okay, the code suggested to rounded value of N. Okay, but in some other books, they are using the exact value of N. Although there is a difference, but negligible if we consider the moment capacity of the section. Let's say that's less than 5%. So hindi siya ganun magkakaroon ng effect dun sa design. Okay, so can you compute for the value of N? So once we solve the value of N, okay, makukuha natin yung moment of area below. So the moment of area below is equal to NAS, N. So ang AS natin is the area of 3 by 328 millimeter diameter bars. So NAS times D. So the distance from the centroid to the assumed, okay? So this one is 500 millimeter. Okay? So ano yung value ng N?
Eight po.
8. So yun yung round depth of na 8. So just rounded ng 8. So from this, ano yung moment of area below? Calculator. Anybody? 7.39 times 10 to the 6. So 7.39 times 10 to the 6 millimeter cube. Okay. So from this result, moment of area above, okay, is 4.5, which is less than moment of area below. So which means, okay, na yung neutral axis natin, kasi mas maliit yung moment of area above. So ibig sabihin, kailangan yung neutral axis natin mas mababa pa dun sa assumed value natin. So therefore, the neutral axis is located below the junction. So if the neutral axis is located below the junction, so this will fall under irregular section. So hindi natin pwedeng gamitin yung derived formula natin for rectangular beam. Kasi pag nag-fall siya, okay, within the flange, so hindi mo na kailangan kunin yung moment of inertia. You can use directly this formula. Kasi parang rectangular section lang siya. So mas madali yung solution ng problem. Okay. Yung nga lang, sa regular section, mas mahaba yung solution niya kasi you need to determine the moment of inertia na yun yung kadalasan nagiging error in solving for the moment capacity of irregular section. Okay? So, next is, so gagawin na natin ngayon, okay? So, this is 100. Then, this one is X. Then, this one is NAS. NAS. So the centroid, from the centroid of the rebar, okay. So this one is 500 sobra. 500 minus X. So in this problem, pwede nating i-cut this T into several triangles, several rectangles. Either this one, okay, or this way. So any will do. So ang pinakamabilis is i-cut natin into 3 rectangles. So if this is 250, the total plans is 900. So 900 minus 250 divided by 2. So this value is 325. So this one is 325. Okay. So moment of area above. So yung basic formula pa rin, moment of area above is equal to the moment of area below. So the moment of area above, okay, so if we consider these two rectangle, so these two rectangle, okay, is 2 times 325, kasi dalawa siya, times centroid. So centroid niya is 50, this one is 50, plus X. 50 plus X. Then another rectangle, this one, the bigger rectangle, plus 250 times 100 plus X times A. So yung centroid niya, 100 plus X divided by 2, which is equal to NAS. So yung N natin is 8. AS natin is area of 328 millimeter diameter bars. And AS times lever arm of 500 minus X. So this will give a quadratic equation. So you can directly solve this using your calculator. So we can now solve for the value of X. So please solve for the value of X.
Hello, sir. Nakamute po yata kayo.
Okay, nakamute pala ako, sorry. Okay, so okay. So, thank you, Alisa. So same answer with Adriana, 1112.115. Okay. So knowing for the value of x, we can now solve for the moment of inertia. So the moment of inertia, again, with these two rectangles plus the other bigger rectangle. So first, the bigger rectangle. So the moment of inertia is BH cubed over 3. Okay, so ito kasi yung kunin natin moment of inertia. So B is 250, H is, so if X is 1112, so 1112 plus 100, 2112.155, BH cubed over 3. So the moment of inertia at the base of the rectangle plus these two smaller rectangle. So the moment of inertia at the centroid plus transfer moment of inertia. So the moment of inertia about the centroid is 325 BH cubed, okay, 100 cube over 12. Kasi dun tayo sa, ang reference natin dun sa centroid. Plus, okay, transfer formula for moment of inertia plus AD squared. So the area is 325 times 100, which is the area, times d squared. So d squared, okay, center of this is 50 plus x, which is equal to 162.155. Nope. Okay. 162.155 squared times 2 kasi dalawa yung rectangle natin plus, okay, tapos tayo sa taas, next is the moment of inertia of the equivalent concrete section, yung AS natin. So NAS, okay, NAS times D squared. So take note that theoretically, meron siyang moment of inertia. Centroidal moment of inertia, yung equivalent steel section natin. Kaya lang, unknown naman yung values natin ng H, unknown yung values natin ng B. Although meron siyang contribution, but very small, okay, compared to AD squared. So, it can be negligible. So, in order to simplify the solution, okay, we just neglect this value kasi wala naman tayong value talaga ng BN equivalent concrete section natin. So NAS is 8 times area of 320 diameter bars. Okay, NAS times 500. So yung D natin o yung D natin is equal to 500 minus X. So 500 minus X of 1112.155 squared. So now we can solve for INA. So please solve for INA. Okay, so INA is 4.78 times 10 to the 9. Okay, thank you, Adriana. So 4.78 times 10 to the 9 millimeter to the 4th. Okay. So yun naman mahirap sa sa pag-determine nung moment capacity. Pwede kayong magkamali sa pagkuha ng X o sa pagkuha ng value ng centroidal moment of inertia. Okay, so once you determine the centroidal moment of inertia, so next is we can now determine the stresses or the moment capacity of the section. So this one, in the problem, we are required to determine the flexural moment capacity, meaning bending moment capacity. So in determining for the bending moment capacity, okay, so we need to solve the capacity considering steel and the capacity considering concrete. So again, the basic formula, stress is equal to MC over I. So that's the basic flexure formula. So if we consider concrete, okay, so FC is equal to moment capacity of concrete times C of concrete divided by I and A. So take note that the I and A here is based on the equivalent concrete section. So meaning, hindi natin kailangan divide ng N. So the allowable stress of concrete, okay, FC is 0.45 of F prime C, which is equal to 28 megapascal. So MC, so the distance from the outermost fiber, okay, from the outermost fiber of concrete to the neutral axis is 100 plus X, which is equal to 212.155. Okay. Divided by INA of 4.78 times 10 to the 9. So take note that all units are in Newton and millimeter. Okay? So lagi tatandaan na always, okay, always convert all your units into Newton and millimeter para hindi nyo na kailangan isulat pa yung units niya. Okay, so from this, we can now determine for moment capacity of concrete section. Then for steel, considering steel, the moment capacity Fs is equal to Ms times Cs divided by I and A. So, but in this case, since we are considering steel, so we just divide I and A by N or modular ratio. So for grade, so this one is grade 60. So for grade 60 steel, the allowable stress Fs is equal to 170 megapascal. So in some other books, they're using 170, the others are 165 or 160. Okay, so anyway, lagi namang as long na you specify on your solution na you use 170 or 165, any assumption will do. Pero hindi pwedeng sabi mo grade 60 pero 140 megapascal. Of course, mali na yon because 140 is for grade 40 reinforcing bars. So 170, okay, MS or moment capacity steel times CS. So in this case, ang CS natin or the distance from the centroid. So take note that in concrete, we use the outermost fiber. But in steel, we assume to be at the centroid kasi hindi naman natin alam yung outermost fiber ng steel. Okay? Although in this problem, the diameter of rebar is given, okay? But in practice, we are not considering the outermost fiber of steel reinforcement. Rather than we use the centroid of the steel in consideration of the CS. So in this case, 150, okay, 500 minus X. So 500 minus X. X is 1112.155. So divided by INA, 4.78 times 10 to the 9 divided by N is equal to 8. So MS, okay. So can you solve for MS and MC? Okay, can you solve for MS and MC, please? Okay? Ay, sorry, nakamute pala ako. Okay. So, from that, that value of MC and MS, or moment capacity of concrete is 283.89, while the moment capacity of steel is 261.9. So this means that the steel will fail first prior to the crushing of concrete. So a good design is kailangan mag-fail muna yung steel bago yung concrete kasi uh, as you will remember, if you recall from your testing materials, pag nag-test kayo ng steel, okay, mapapansin niyo nag-elongate na yung bakal. Pero hindi pa siya napuputol. Hanggang malis niya yung required elongation, saka pa siya maputol. So, in analogy to the building, so makikita ninyo yung beam ninyo prior to complete collapse of the structure, magka-crack muna yung concrete sa bottom. So, that means na nag-yield yung reinforcement natin. So, merong pang time, okay, yung occupant ng building to go out, okay, for safety, makakalabas pa lahat ng occupants niya. Unlike na mag-fail yung concrete natin, diba sa testing of materials, nag-test kayo sa universal testing machine, wala kayo nakikitang sign. Okay? Wala kayo nakikitang sign na cracking ng concrete bago siya mag-fail. Instant, pag nag-fail na yung concrete, nag-crack na siya, bigla siyang bumibigay na. Kaya, yun ang lagi tatandaan sa design. Laging mag-fail yung steel reinforcement before concrete. So yung moment capacity niya will be 261.9 kilonewton meter. So that, okay. So itong is not only applicable for T-beam but also for rectangular section. Any section, okay, either triangular or hollow section, okay. So itong solution na to is applicable. Basta WSD, okay, applicable tong formula na to. Ang bonus lang dun sa derived formula is mas mabilis yung compute. Saka less errors kasi hindi na kailangan solvein yung centroid, yung moment of inertia. Unlike this one, makuha niyo yung value ng K, makuha niyo yung J, you can solve for MS and MC. So yun ang difference. But kung alam niyo yung beam formula, hindi kayo magkakamali doon sa pagkuha ng moment capacity ng section. Okay? So any questions? Or any clarifications? Kahit triangular section pa yan. Okay, ganun din. Sa triangular section, okay? Sa triangular section, ito arbitrarily chosen nyo na centroid. Okay, so ito yung X. So, yeah, this is B. So, ma-relate, although this one, two unknowns, X and base ng smaller triangle, but using ratio and proportion, makukuha nyo yung base in terms of X o makukuha nyo yung X in terms of base. Yes? Any question?
Clarify ko lang po sir, yung sa FS po, kapag grade 40, 140 po, tsaka kapag grade 60, 170.
Yeah.
Paano po sir kapag ang given sa problem po ay FY? May mga na-search po kasi kaming problem, FY po yung
okay.
given. Hindi
So,
sinabi ko ano
FY,
pong grade.
So yung FY kasi, pag grade 40, yung FY kasi stands for the yield strength of the material, the minimum tensile strength of the material. So for grade 40, ang FY niya is 275 megapascal. For grade 60, ang FY niya is 415 or 414 megapascal. Okay? So pag 275, automatically yung FS niya is 140 megapascal. Then for 415, yung FY niya either 165 or 170 megapascal.
Thank you po sir.
Okay? So some more clarifications?
Sir,
Tanong ko lang po, kapag exam po, kayo na rin po ba magbibigay if 165 or 170? Kasi parang
Yeah, sige, pwedeng ako na magbigay. But if, for example, hindi ko naibigay yung FS niya, either you can use 165 or 170, okay pa rin yun. But of course, for example, sinabi ko grade 60 pero bigay 140, automatically mali yun. So, pwede siguro isang problem, bigay ko yung in FS niya. Then, yung second problem naman, other problem, bigay ko yung grade lang ng bakal para masanay kayo.
okay po, thank you po.
So, may questions pa? Meron pang questions? Then also in the problem, of course, before you can design the beam, you need first to determine the moment of the or required moment or the actual moment of the structure. So hindi mo lang kailangan reviewin yung RC design, but of course, kailangan nyo balikan yung Theory 1. Okay? So yung analysis ng frame, moment distribution, although there are several methodology or methods in determining for the moment of the structural analysis, okay, or moment of the frame. But the best na nakita ko is yung moment distribution. So kailangan magpamilyar ka sa moment distribution kasi pwede ko ibigay na i-design mo tong beam na to, but the only given is the loading. In our problem, it just so happened that to shorten the discussion, given na yung moment or yung section capacity na lang. But in the exam, pwede kong ibigay yung frame, then with given loading. Or vice versa, given ko yung section, section ng beam, either rectangular or irregular section, then find for the W or uniform load to be carried by the beam na shape. So, kailangan nyo balikan yung yung Curie structures nyo, Curie 1, Curie 2. Yung moment, especially moment distribution. Ito yung pinaka easiest way in determining for the moment sa frame analysis. Of course, hindi ako magbibigay ng ng mga theoretical section. Okay? Hindi ako magbibigay ng bilog na merong dalawang bilog na void. Okay? Ang bibigay kong problem is yung yung practical section ng beam, either rectangular, triangular. Although yung triangular very seldom na ginagamit, but this one is used sa mga exposed beam. Okay? The purpose of this is para hindi magkaroon ng panding on top of the beam. Kaya ginagigil siyang triangle o kaya inverted U-beam. Okay? So yung U-beam naman natin ginagamit sa mga gutter, okay? Mga concrete gutter natin, U-beam or I-section. Okay, yung I-section which are used in the bridge construction or hollow section. So yung hollow section, ito ginagamit sa mga if there are cases na sometimes merong mga lines, mga electrical lines, o kaya communication lines na kailangan natin i-protect pag magamit tayo ng hollow section. or sometimes voided, mga slab. So may mga cases na voided slab. Okay? So the purpose of this is to reduce the weight of the beam o the slab o the structure. Okay? Kasi di ba sa design ng beam, makikita ninyo, yung rectangular beam, ang effective lang na concrete section is yung section above the neutral axis. Okay? So the section of the concrete below the neutral axis is disregarded in the design computation. Although meron siyang tensile strength, but very small, almost around 5% of the compressive strength. So masyadong maliit, negligible siya, although may strength siya. So kaya using this hollow section, kunyari, ang nakuha mong required section mo lang ng concrete is 20 mm. So pwede mo siyang ihalo. So yung 20 mm lang ang solid, tapos yung below niya, pwede ka na maglagay ng mga pipes, okay? Or any rectangular o kaya tubular o circular pipes kasi hindi siya kailangan para ma-reduce mo yung weight ng structure. So kadalasan ginagamit yung mga mga hollow section sa mga bridge slab, okay? Na masyado kasi malaki yung section sa bridge. Okay? Pero sa mga residential construction, pwede siyang gamitin na hollow, kaya lang sa nipis ng slab natin, around 100, maximum 150 mm for commercial building. Okay? Pwede mo siyang gamitin, kaya lang if you are considering the cost, baka mas mahal pa yung cost ng tubular or pipe section mo. Unlike for the bridge slab, yung bridge slab, okay, ranges from 850 mm or 600 mm to a maximum of 2,500 mm. Okay? So dito, compared to the cost of hollow section, kasi kung compare mo doon, magkano yung concrete area na ma-reduce mo compared to the hollow form. So once the cost of the concrete is greater than the cost of the hollow section, so pwede mo gamitin yung hollow section. So first benefits is gagang yung structure mo. Second, magkakaroon ka ng cost cutting, meron kang savings. Okay? Third is yung hollow section mo kasi pwede mong gamitin na either yung mga styrofoam or pipes. Minsan may ginamitan namin ng mga PVC pipes. Okay? Kaya lang ngayon medyo mahal yung PVC pipes, kaya ngayon kadalasan ginagamit namin sa mga hollow section is styrofoam, yung mga high density na styrofoam na available naman sa available sa mga industrial supplies. Or sometimes combination ng hollow. Kahit nga yung minsan yung mga poste ng mga bridge, kasi mga poste ng mga bridge, meron kaming poste na sobrang lalaki talaga. Okay, ang size niya 10 meters by 2 meters. Imagine more than double of the standard room. Okay? Samantalang pag bridges, ang kailangan mo lang na section ng concrete sometimes. Kasi pag bridge design, more on reinforcement. Napakaliit nung contribution na strength ng concrete kasi although compression member siya, but during seismic, more on flexural yung nag-govern sa design ng mga matataas na bridges. And it's also with the high-rise structures, mga ground floor natin, pwede mo siyang ihalo, okay? Lalo na pag limited lang o naka-pre-stress ka. So pag naka-pre-stress ka, malayo yung column mo. So yung size ng column mo, lalaki siya. Okay? So para mabawasan mo ng weight, pwede mong ihalo yung column design mo. But again, of course, before you do that, kailangan checkin mo rin kung magkano yung cost no matitipid mo konkreto versus dun sa formworks na gagamitin mo. Okay? So any more questions? Okay? May questions pa? So regarding WSD? So I hope na ma-perfect niyo yung yung first exam niyo kasi ito na yung pinakamadaling exam, yung WSD. Tapos sa mga succeeding na natin na lecture natin, so dito, i-recap natin WSD in two meetings or 3 meetings. But next kasi yung principle ng WSD saka USD, parehas lang naman. Ang difference lang nun is yung magkaiba lang yung load combination niya, may factor na siya. Tapos iba na yung distribution ng stresses ng concrete. Okay, so dito, we assume that the stress distribution is linear, but in ultimate strength design, the stress distribution is parabolic, not anymore linear. Okay? Kasi ginagamit na din yung iba na yung stress mo dun sa sa top, iba na yung stress mo sa bottom. So triangular lang siya. Pero pag ultimate strength design, parabolic na siya. So starting from this stress, tapos habang naglo-load ka, lumalaki siya hanggang dumating sa point na magpipila siya. Habang malapit sa failure mode, lumilit na yung stress niya dun sa neutral axis. But in parabolic, okay? Parabolic curve, not anymore triangular or straight line. Okay, so next meeting, so we'll be discussing rectangular, irregular, and doubly reinforced. Okay, in only one meeting for WSD. USD pala, USD. Kasi at least meron na kayong basic concept ngayon ng working stress design. So alam niyo na yung principle sa T-beam, regular, saka yung principle ng double reinforced kung paano siya, bakit naging double reinforced siya. Okay? May questions pa?
Sir, question po. Para dun po sa exam, sir, yung schedule po ba bukas na po talaga? Kasi meron po kaming klase, sir. And
Yeah, okay lang. Sige, to give you more time to review, you can suggest any schedule. So within it can be within next week before the lecture, Friday lecture. So any day will do, anytime.
Okay po, sir. Pag Friday po next week, sir, rin po, the same schedule po natin or mapapaaga po?
Siguro mas maaga kunyari para yung lecture natin 6 to 9 pa rin, ma-discuss ko yung 3 topics sa USD. So either, kasi 1.5 hour yung exam, 2 problems. Okay, so 1.5 hour. So you can choose either 4:30 to 6 or earlier.
Okay po, sir. Tapos last na po, synchronous din po yan, sir.
Yeah, but in the exam, okay, I required to open your camera during the exam. So same link. Okay? So, dapat naka-on cam lahat during the exam.
Ay, sir, sorry po. Wala po atang pasok next Friday, sir. Manila Day po.
Ay, ganun ba? O nga, no?
Sir,
Yes.
pwede po bang sa Thursday po yung exam? Sabay-sabay po ba yung 3 section mag-exam?
Yeah, sabay-sabay. Okay naman Thursday, basta as long na available kayong lahat.
Ano po, may exam po kami nun, sir. Medyo mabigat din po
Okay
yung
na
subject po namin.
Sige, pag-usapan nyo muna kung anong day and time kayo available lahat. Tapos, i-message nyo lang sa akin para doon ko, at least one day before your chosen date and time para may prepare ko yung exam.
Hello, sir. Yung PPT po, pwede po ba namin itong mahingi? Itong may solution po.
yung, ito?
Point opo, sir. Yung
Sige,
resume
sige.
po.
Upload ko sa Google Classroom.
Salamat po, sir.
Okay. Okay, may questions pa? Okay, may questions pa? Sa Friday, ayaw niyo magklase kahit holiday? Pwede rin namang kung gusto niyo mag-exam ng holiday para at least siguradong pare-parehas kayo na available. Basta pag-usapan niyo na kung anong preferred time and date ninyo.
Sige po, sir. Pag-usapan po muna, sir.
Yeah,
Tapos
sige,
update
pag-usapan
po
ninyo.
namin.
Yeah, okay. At least one day para may upload ko yung exam
Opo,
sa
sir.
Google Classroom.
Opo, sir.
Okay, may questions pa? Okay, so wala nang questions. You can still message me sa Messenger kung meron pa kayong clarifications before the exam para masagot ko. Okay? So for that, thank you everybody and have a good day everyone.
Thank you po, sir.
Thank you po, sir. Thank
Thank
you.
you po.
Thank you po, sir.
Thank you po, sir.
Thank you po.